Hey guys, this is Tori from Hats Tutors, and today, as part of our Basics of Organic Chemistry series, we're going to be discussing how to name haloalkanes. So haloalkanes are alkanes that have a halogen, so fluorine, chlorine, iodine, and I missed it here, but also like bromine bonded to them, and they're also known as alkyl halides, and they're represented by this kind of a structure, where X is the halogen. So how do you name haloalkanes? To name haloalkanes, one would first apply the general rules of naming. Although halogens are generally ranked higher in priority than alkanes, the numbering actually does not change. So what I mean is, for instance, remember when we're naming alkenes, the we would prioritize naming the double bond rather than, for example, substituent, such as in this case, this would be the substituent, but you would prioritize the double bond. But in the case of haloalkanes, there's really no priority, and let's just say instead of double bond, we have like a haloalkane here. You would number it the way to reduce the overall numbering. In this case, it would still be from left towards downwards, I guess. But let's just say if this was the haloalkane and this was a regular methyl substituent, you could name it the other way as well. You should name it this way, not like the other way with the haloalkane included first. So after applying those rules, add the halogen group as a prefix, similar to naming alkane substituents, and add the carbon number before the prefix. So in this example, the halogen is on the fourth carbon, so you would do 4-chloral, and the prefix would be the name of the substituent, omitting part of it and adding rho. So it would be like fluoro, chloro, bromo, iodo. So naming halogens continued. So this is where I show you, and there's also bromine, and that would be bromo. And as you can see here, this would be 2-chlorobutane because the main chain is the butane, and there's a chlorine attached to the second carbon of the chain. So let's just go through naming some halogens then. So let's start off with this one. Let's identify the main chain first. So from what I see, you can start the main chain from any one of these carbons, and it would go like, it would cover this carbon, this carbon, this carbon, and this carbon, and any one of these. So let's start naming. So naming this direction should minimize the overall numbering because the halogen groups are attached to the first carbon, whereas in this case the methyl groups are attached to the second carbon. So you would name from right to left. So let's just take a look. There's three bromines, three bromines, one fluorine, and two methyl groups. From alphabetical ordering, we know that the bromine groups should go first, then the fluoro groups, and then the methyl groups. So it would be something like 1, 1, 3 tribromo, 1 fluoral, and 4 dimethyl pentane. And that would be the name of this this molecule. And in this case, we can see we actually have a double bond here. So recall that this kind of looks similar to the cis trans isomers we were talking about last time. So let's just take a look to see if this is actually a cis trans isomer. So in this case, this is actually not a cis-trans isomer because we can see here that the weights, or like I guess the atom priority on both sides, are actually the same because these two sub-branches are actually identical. So you actually don't need cis-trans for this. So then you just go by alphabetical ordering. So it would be dichloral, 1,1-dichloral, and 2,2-difluoral. Ethene. So that would be this molecule over here. So let's go on to drawing haloalkanes. So like all drawing diagrams, we would start off with the main chain first. So let's just draw a hexane. So this would be a hexane. And now on the second carbon, we add 2 bromines. So bromine, bromine, iodine on the third carbon, and methyl on the fourth carbon. So yeah, 2,2-dibromo, 3-iodo, 4-methylhexane would look somewhat like this. And let's just go over some quick properties of haloalkanes. So haloalkanes actually are special in the sense that they're not special, but like these are some of the properties that are featured. So in terms of bond length, bond strength, and molecular size, so these properties are actually all derived from the atomic trends. If you learn about atomic trends, and basically for the bond length, we know that like the carbon fluorine bond is smaller than the carbon chlorine bond, and so on, because we know that as as you go down a group, the atomic radius increases. So like iodine's atomic radius would be greater than that of fluorine's, and that means that their bonds are gonna be longer, right? And bond strength, since that the bonds are going to be longer and their nucleuses are going to be further apart, that's why the two that are closer, so carbon and fluorine, are the strongest in terms of bond strength. And molecular size, well, this, as I was talking about, was the atomic trend of like how big the is atomic size. Like this is how big the fluorine atom is. It's smaller than all the others, and as you go down the group, the size increases. So boiling point of haloalkanes versus alkanes. So this was a slide that I wanted you guys to consider. Oh, what are what is the boiling point of haloalkanes? Are they relatively the same as the alkanes? Well, I'll just give you guys 5 seconds to consider this. So now I'll tell you guys the answer, and if you don't want to hear the answer, you can pause. But basically, the boiling point of haloalkanes, so boiling point halo, is actually greater than the boiling point of alkanes, and this is due to intermolecular forces. So boiling point is determined by intermolecular forces, and we know that haloalkanes, since the electronegativity difference, so delta En, caused by the halogen, would actually make the bond polar. So that means that haloalkanes can experience forces like dipole-dipole, whereas alkanes can only experience forces like London dispersion. And dipole-dipole intermolecular forces are stronger than London dispersion forces, and that increases the boiling point of haloalkanes. And we're finished. I want to thank you guys for watching, and if you guys have any comments, please leave them in the description. And during these precarious times, please stay safe. Thank you.